Good afternoon, everyone. So I'll start with the session now. Screen is visible, right?
Sir, visible, sir.
Yeah. So now we'll start with one more topic called neural network. So all the members can open the folder internship code level 2 is there. No? There we get two documents. One is neural network class and one more is CNN. So both the documents, you can just open it. So this is the document with the neural network class, and one more doc. The first image you'll find like this with a bird. That is the CNN.
ನಮಸ್ಕಾರ ಸರ್. ಅದು ಓಟ್ ಸೆಟ್ ಆಗಿಬಿಟ್ಟೈತೆ ಸರ್. ನಾಳೆ ವೆಂಡಿಟ್ರಿ ಫಂಕ್ಷನ್ ಐತಲ್ಲ ಸರ್. ನೀವು ಇನಾಗ್ರೇಷನ್ ಆಗಿದ್ರಿ ಸರ್. ವೆಂಡಿಟ್ರಾಗ ಅಜೆಂಡ್ ಆಗಿ ಇಲ್ಲ ಸರ್. ನಾನು ಓಟ್ ಸೆಟ್ ಆಗಿ ಅದೇ ಸರ್ ಓಟ್ ಸೆಟ್ ಆಗಿ ಮೆಸೇಜ್ ಮಾಡಿದೆ.
Okay. So this is the CNN document. A lot of theoretical concepts are there in this document. So I'll be using that document for today's explanation. And one document is there with a neural network. So you can observe some of the points mentioned here. So just all of you can just go through with those points. Observe these images which I have mentioned here. So that I can start with the explanation. I'm just waiting still a few more members to join. Within some 2 minutes, I'll start it. Meanwhile, all of you can just open these documents and observe the images and the points which I have mentioned. Okay, so I'll start now. So this is again a theoretical session where we'll try to understand what is the concept of neural network and CNN, how the theoretical concept works. So now we'll see internal concepts about neural network, and then with the convolution neural network. Later we will enter into one example, taking an image as a data set. So that today and in tomorrow morning session I'll complete it. Okay. So we can see the few statements which I have mentioned here. So neural network. So again, it's a part of AI. From in the day one class, I told a lot of technical topics or domains we are going to see under AI. AI is just a general concept in that a number of concepts are going to come into picture. So AI is a combination of algebra, mathematics, probability, statistics. So we saw these things in all these classes, right? Okay. Then artificial neural network. Again, it's a type of machine learning concept. So if someone tells this project is done with neural network, means nothing but it's a part of a machine learning. Okay. So these things we call it as an artificial neural network. Artificial neural network, which is one of the main building block of artificial intelligence. Different variants comes in artificial neural networks, means multiple types based on the problem statement. Based on the input, we have multiple types of artificial neural networks. So in that one, one is called as a CNN, convolution neural network. So which is mainly used for image concerns. Whenever we have our inputs in the image format, CNN is much more preferred. Okay. So CNN is used. This is one of the standard algorithm, proven algorithm at present, which is used. So CNN algorithm is used for the image inputs. Then RNN means recurrent neural network are used to solve some sequence problems, some sequential oriented problems and all will be handled with the RNN algorithm. So in our class, we'll see about the CNN with some image examples. We'll work on CNN. So the libraries, so here, whatever we work on Python, we know that for that some libraries we need to understand. So here the libraries used for our neural network activity, one is Keras and TensorFlow. Both are integrated. Before TensorFlow was it was from separate algorithm. Now both are integrated. So slowly we'll see everything under the control of TensorFlow only. Okay. So Keras and TensorFlow library packages are used over here. Here I have mentioned short form. So you can see in the reverse order, like DL means deep learning. See, someone tells like the project on deep learning means deep learning itself is a part of a neural network. As the neural network comes with much more complicated things and all, it enters into the deep learning features. Okay, so deep learning is a part of neural network. Again, neural network is a part of machine learning. So in machine learning, we saw supervised, unsupervised, right? So that is a one type of machine learning. Handling the problems of AI with the supervised or unsupervised algorithm methods are different, and handling the problems of AI with neural network methods are different. Okay, so the whole neural network theory is different. According to that, we can handle the problems of AI. Clear? So if someone tells neural network, even that is also a concept of a machine learning. It's clear, but we can't take it under like supervised, unsupervised in that format and all. Here, the way of handling is different. So here also you can take the data with the standard, which is mentioned with the output class. Okay. Then, as we know, machine learning is a part of AI. So the applications of neural network right now we can see like in all these areas it is used. Any problem, any task can be handled with neural networks. So right now, translating text translate like multiple language translations, all those things. Identify face recognition activity can be done with the neural network. Speech related activities, handwritten text identification, robotic fields. Okay. So we would have heard about Google, Siri, all these things, right? So mobile assistants, products, then self-driving car. So many applications in all those areas, neural network concept can be used. Okay. So first we'll see like what is neural network, how that concept works. Then we'll get into the next part. See, you're finding some image here, right? So in this image, you can find some circles here, which is represented in the vertical format, and n number of lines are drawn between these circles, right? So from one to one, many lines are drawn, right? So these are called as a layers. Okay. So this vertical circles are called as a layers. This is called as an input layer, and the middle two are called as a hidden layer, and the last one is called the output layer. The first point to understand with the neural network is whenever we find these kind of images, okay, with multiple layers interconnected and all, so then it is a concept of neural network. This image represents it's a concept of neural network. So neural network is basically divided into three parts. One is the input layer, then hidden layers, and the output layer. Input layer will be one, output layer will be one, and hidden layers it can be more than one. 1, 2, 3, 4 depends on the concepts. Clear? So there can be n number of hidden layers. The first point to understand is input layer. Then it can be a multiple layers of hidden layers. Then with the output layer. Clear? Okay. So this is the first point of neural network. Next. So we'll see like a little bit how these neural networks are handled. So a few points I have mentioned here. Neural network requires clear and informative data, and mostly big data. So when data is huge, we get into the field called of data analysis, big data concepts and all will come into picture. So obviously means one important thing is for a neural network, the data should be very huge because it works in that kind of concept that if the data is very good, the training will happen in a much better way. So more data is required for the neural network. So here with some child example, one concept has been told. So I'll just read out. So you can just go through with that. So the neural network, we can think like a child brain. So not only for neural network, whenever we want to understand anything with machine learning, we can think like a small new kid child brain. So the similar examples we find in many concepts for explanation purpose. So here they are taken example with respect to the walking, as the child tries to walk by itself with some parents guidance supports and all. So as it keeps every step, it's going to perform with some task, right? And it's going to do mistakes also, like falling down, all those things happens, and then it attempts, so that slowly the child is going to learn. So over a period of time, we can see that the child is going to walk in a better way. A newborn baby is with empty mind, right? So we train it, we give the data for the newborn baby, so it observes the data as like how we are walking. Then we give some support for the child. So with that, it starts of learning with all the mistakes followed on so and so process. The child will learn to walk in a better way. So the concept is, as much as more exposure we give, more data we give, more corrections we add it, the feedback methods and all, so the results will be much more better. So here all the outputs are spoken with respect to the percentages, like predictions. So means how you get the better predictions, better results, how we can achieve. There is nothing called 100% kind of thing. Always we will try to achieve that one. You can't achieve 100%, but the try will be there always, where we can get it towards that 100%. So that better things, if you want to achieve, then multiple iterations and cycles will be done in the neural network concepts. Next, hardware requirements are essential for learning deep neural network concepts, because why hardware requirements? Because huge data is there, so much data we have to process it, right? Now assume like you have images, like how our eye is collecting all the data. So same way your camera starts of collecting images continuously, and if you give all those data to the computer brain to process everything image, it takes a lot of time. So simple way to understand, assume like you connect a pen drive. Okay, in a pen drive you keep some 1,000 pictures and copy it to the hard disk. Just copying a file from one device to the, means your pen drive, external device, to the hard disk, it takes a lot of time. It's just copying, it's not trying to analyze it, right? So only the copy process will take in terms of some minutes, where it is taking the data and it is storing in the hard disk, right? Now when you run a neural network system, it will be work with the individual pixels, every small pixels, where it's going to apply some mathematics, some calculation, analyze that one, then get it to the next level. So every image it will pick up and it's going to apply some concepts on it, some formulas will be running, right? So if you are copying just an image from pen drive to hard disk, an image is taken and it is copied, means again in the pixel format only it is copied over, because in computer whatever is stored, it is in the binary format, right? So in the bytes format. So all the data are passed, but just pick the data from one place to and give it to the other place. But here in neural network, it is going to pick that data, it's going to analyze that one, it's going to do to some order and then keep it again, right? So while doing this thing, obviously it requires a huge time. If you start up running at present, whatever our i3, i5 computers we have, if you start up running with a neural network concept with almost around 10,000 images, it will get hanged, it will get stuck. So our computers are not into that kind of efficiency level. Computers means I'm speaking with the general consumer market, not with all the high-end products which are used in industries or in the servers. But still a lot of changes has to happen. So that's why all these terms are spoken for the next generation level technologies. So the whatever the speeds we have at present are not up to mark. The speed has to increase in a different format. Okay, so all these neural network activities requires a huge hardware configurations. So now we'll get into the technical part. So whatever I explained about the first layer, that is the input layer. So we can see like neural network is having multiple layers. The first layer is the input layer, and next that data is passed to the next layer. Generally those are called as a hidden layer, which will do all the calculations of feature extractions, whatever is there, that will be done in the hidden layer. And there can be more than one hidden layer also, and finally there is an output layer, right? So basically any neural network concept runs with 3 layers. Okay, now So now we'll get into the example, like a traffic camera you want to identify the vehicle number plate, or near toll gates number plates you want to identify, means we have to find out the images with the numbers, right? So numbers we know with multiple shapes, no? So the letter 9 is written like this. Someone can take this curve in this format. The digits or alphabets are written with the different font styles, right? So in real time, when you have a data with multiple font styles, detection is not that easy. It's really complicated. Right now, a lot of algorithms have come out in the market for it. Fine. Okay. So if we take that example with the number plate and all, now we'll go with the individual digit. Taking here with this image a digit of 9, we'll see like what all concepts comes inside the neural network. Okay. So now assume that digit 9 as per that image. This image is a size of 28 by 28 pixels we are going to consider. Okay. That image is fed as an input layer, right? So this single image is passed as an input layer for the neural network. See, this is the number 9, digit 9 is there. So this is one image now. Assume this is an image of a 28 by 28 pixels. In this image, we have a digit 9. So this is passed as an input layer. So what input layer is? This digit 9, now we have 28 by 28. When you multiply that one, you will get a 784 pixels. Okay. Each pixel is passed as an input to the neural network. That acts as an input layer. Clear? So each pixel acts as an input to the neural network. So the combination of each pixel will be acting as an input layer. Fine. So now we'll see this explanation now. The input image is 28 by 28 pixels. The image is fed as an input layer. So each pixel will be passed over there. Each neuron has a number called activation. So this pixel, what we call, right? Normally when we see, there is a slight terminology difference with respect when we speak with normal images and when we speak images passing to the neural network. Here, when we speak about normal images wise, we speak each pixel, right? Each pixel we tell. Here we are going to tell it as a neuron. We call it as a neuron. Each individual pixel in neural network concept, it is called as a neuron. And the pixel value, when we tell with the color images, it was with color or grayscale. When we speak about images, it was from 0 to 255. Here the pixel values varies from 0 to 1. And for neural network, always it is taken images in the grayscale format. Clear? No color images, you have to convert it into grayscale. So for neural network, it is taken in the grayscale format. So I'll repeat it. So any image is there. Now we are taking an example image of 9, where the handwritten number 9 is there in that image. Where the overall size of that image is 128 by 128 pixels. So altogether it comes around 784 pixels. In neural network, each pixel is called as a neuron, right? Second thing is each pixel or each neuron will be having a number. When we speak about normal images, that number varies from 0 to 255, which we call it as an intensity value. Here we call it as an activation. So called as a activation. Each neuron has a number called activation, and this number varies from 0 to 1, where 1 represents white and 0 represents black. So for neural network, our data should be always in the grayscale format. Clear? And it can be some other fractional values also. See, one activation number has been mentioned here. It is 0.98, right? Sorry, 0.58. So it will be value from 0 to 1. Clear? So the first point, so few points we should learn about neural network as a theory. So that part I am covering now. So grayscale image, 0 to 1, 0, 1 means white, 0 means black. It can be a fractional value, which is called as a activation. Fine. Okay. Now, so that number 9, what we are able to find here, see the number 9 is there here. The image of 9, it is like a handwritten format, 128 by 128, 74. We saw the activation number also of each neuron, right? Now, Each neuron set of 784 acts as an input layer that is passed to the hidden layers. You come out with the result. See, this is what you are passing as an input. The output class, here it is varied from 0 to 9. Total 10 class we have, right? Output class. So out of that, when it detects, when you give the input of number 9, if it detects the output class as 9 means the prediction is correct right now. So the output class is 9 here. Okay. So now all of you can observe this image now. So now we'll see a little bit more depth in the technical concepts. Just a moment. So the previous we saw with the digit 9. Now this is another image, right? So in this image, what is the class we are able to find? What is the output class? Can anyone tell by seeing those images? What classes are there or what is there in this image? Output class. Any member? Input layer, output layer. So output class by observing that image. By observing that image, any member can tell what is the output class here?
3 output class, sir. No, 1 minute.
See, in the previous image, we can see the output layer, right? That is the output classes represented over here, which you can see like it is from 0 to 9, right? So same way, this is another image. In this, what output class we can observe there?
3 different classes, sir. Squares,
Yeah, three classes are there. What it is?
squares, circle, and triangle.
Right, correct. So you can see that this is one input image. So in this input image, you can see these white portions, right? This represents as a circle, right? No. So we are providing one input image with neural network and all. It has to find out the output class. There are total 3 classes here. One is the square, circle, and a triangle. So when you are giving a circle, so if it detects the circle, it is marked with yellow color here. If it is detecting the circle, then the overall prediction is correct, right? This is another image where we have taken an example of about the shapes like square, circle, and a triangle. Now, see, a lot of some numbers are mentioned here. So next concepts we will try to learn now. So till now, what all we learned, I'll just brief it, taking this another example. So neural network. So input layer, n number of hidden layers can be there. 1, 2, 3, 4, how based on the concept. Then one output layer, that is the output class. Okay. So this image is here we have an input layer of 128 by 128 pixels. So it comes around 784 pixels. Here in neural network, each pixel is called as a what?
Intensity.
No, pixel value. Normally when we speak about neurons. So each pixel is called as a neuron here. And when we speak about normal images, each pixel will be having a value that is called intensity, which varies from 0 to 255. Here we call that each pixel value as a activation, and that varies from 0 to 1, where 1 means white and 0 means black. And it can be a fractional value like 0.25, 0.39, 0.97, like that. Clear? Okay, this was the basics. Each pixel set in a form of an array that comes around 784 is passed as an input layer. So now this input layer is passed to the hidden layer. Okay. Between the input layer and hidden layers, or between one layer to other layer, we are finding some lines, right? These are called as a channel. Okay. So each circle, what we are finding, this is called as a neuron, where you are finding x1, x2, it will be activation number, which varies from 0 to 1. Any decimal number can be there. Then from one layer to another layer, the lines what we are finding, it is called as a channel. For each channel, some bias value is assigned, that itself again a number in some decimal values, that is called as a bias. Okay. Internally, the algorithm will assign based on some concepts, the bias values will be assigned. Not bias, just a moment. Sorry, weights. Sorry. These numbers, what we are finding for the channels, it is called as a weights.
Weights.
Then based on the concepts of this channel combinations and with the weights, we get something called as an additional factor, that is the bias. So based on this bias, channel, weights, neuron activation, there is a concept which will happen as a small formula you can observe here, which is called as an activation function. Based on this activation function only, the next layer is formed. Clear? So I'll repeat it everything once again now. So as per this image, some more information we are trying to learn now, how the neural network concept works internally. Input layer we came to know. Input layer is made of each neuron which is having a value that is called as an activation. So that is represented as x1, x2, 3 here like that. So you can see small formula example over here. Then the lines connected between from one layer to the next layer are called as channels. For these channels, some decimal values are assigned, which are called as weights. With the combination of these weights, with the combination of activation number of each neuron, then some bias value as an add-on factor, one formula will be made that is called as an activation function. This activation function is nothing but the hidden layer which is formed based on the combination of a bias number, weights, neuron activation number with some mathematical formula. So which we call it as a hidden layer. So activation function is a process to get the hidden layer. So we'll see those definitions now. We observed in the image. So we saw up to here grayscale image we have to pass to the neural network. So now pixels are in the form of arrays are fed to the input layer. So all the pixels which we call neuron in the form of array, it is passed to the input layer. The image you must shrink it down. This is the input layer. So the input layer then passes the input to the hidden layer. The interconnections are assigned with the weights at random. So some numbers comes that are called as a weights. The weights are multiplied with input signal and bias is added to all of them. So some bias one number is there that also gets added. So with that we get something called as an activation function. Okay. So here I just listed some technical terms which all comes with the neural network and CNN. So we saw what is neuron, what is the meaning of channel, bias, weight, activation, function, right? Then remaining these things and all, we'll see it later. And kernel, straddle, stride, padding, pooling, all this comes with the CNN. So all these terms comes with the neural network. Okay. So few of the terms as mentioned a small point here. So what's the meaning of neuron? Already we discussed. Channel. So neurons of one layer is connected to the neuron of another layer that is called as a channel. Then activation function. So activation function we saw in this image, right? We can consider like a simple formula. Some example has been given here. A simple formula which may based on this formula only the next hidden layer is formed. After that again next hidden layer is formed again with this formula, then with the final output layer. The hidden layers can be n number of type. So now when we come to the activation function, there are n number of methods to get into the activation function. So we can see some examples only with the name. I'm not going in depth about it. So we get a type of called sigmoid. We get one type called threshold, RELU, softmax, hyperbolic tangent function. These are all different mathematical terms which deals with the activation function. So in a simple way to get the activation, to understand what it is means, say activation function is a set of some formulas which involves with all these weights, neuron activation number and bias and all, right? So this is one type of formula. Assume like this formula is called as a sigmoid type of activation. If the combination of this formula changes in some other type, then it may be a type of a threshold. If it goes in some other type, then it may be a type of RELU, right? So like this, we get multiple types of activation function. Clear? So whenever we are working with neural networks, if you want, you can configure this activation functions as per your requirement. That is one thing. Second, next is here we are finding a word called as a forward propagation, and below that we can find a word called as a back propagation. Forward propagation means with the input layer apply some activation function which involves multiple values, and you get a hidden layer, then again apply the activation function to get the next layer something. So we came with the final output class, right? So once you run this network, a neural network, we may not end up with the final class. Okay, it may predict like it is a type of a square instead of a circle. It may predict like a type of a square. So we don't know that. Okay, for that again, see with the output class also some weights we can find here, right? So based on this thing, some back propagation method has to be applied, so the network runs with the multiple times. When you apply a back propagation, this happens in the training data. See, assume like you gave a training data. When I am giving this data, I'll tell like this is with the output class circle, right? Now the brain is getting ready, right? The brain is going to work in this formulas concept. So it took the circle. It know applying the formula of that brain, it has to come out with the final answer as a circle only, right? So when you pass your input layer, this assume like this is one training data. So it will apply one method, but it predicted as a square, and it knows that this is not a square, this is a circle, because we have given a training data. Training data means what? All the inputs, and again the output class also we are going to give. So based on this activation layer or formulas and all, it predicted like a square. So the algorithm knows that for that training data it is predicting as a square, right? That is wrong. So it will apply a back propagation, so that adjusting these weights and all in a different format, it will try to get the prediction as a circle. So once it gets the circle, it will note down that. So this is how the things done, and also my weights and all adjusted, and I observed some key points over here. So same way, I'm just telling in one method, like this, lot of things happens internally inside the algorithm. Okay, so same way, now another image came. Again, that also is with the circle only, and the output class is circle. So now whatever the finalized was there, that weight method, again it will apply. In that time, the prediction done correct. So it will finalize it. Now one more circle image, apply that one. Now there some problem, again it didn't predicted as a circle, it predicted as a rectangle, triangle. So again adjust this weight, something, multiple back propagation, forward propagation, this cycle will run multiple times. Again till it gets as a output class as a circle, because we are giving a training data where we are very clearly telling that this input is a circle. So it is not understanding based on its own brain calculation. It is not understanding. Instead of predicting as a circle, if it predicts some other class, it will apply lot of cycles of forward and back propagation till it understands like this is a circle. Clear? So you can find the statement for back propagation here. Error in the output is back propagated through the network, and weights are adjusted to minimize the error rate to reduce and come out with the final answer. So it will be applying multiple cycles of forward and back propagation. Clear? So this is the concept of neural network, like how neural network works, and some main points which comes under neural network that I discussed now. So till now, whatever I explained, if anyone is having any doubts, you can just clarify. Any member, any doubts are there with respect to the concepts which I explained on neural network? You can just clarify it. Okay, so now we saw in neural network, we have two types which I mentioned here. One is the convolution neural network, and another one is recurrent neural network, right? So CNN and RNN. So now we'll see what is convolution neural network. See, scroll down and you can see the bottom one image here. So this image is a concept of a convolution neural network. See, you can find here the right side, this is the neural network, right? To pass your input image, so the image here, some digit 4 is there. to pass to the neural network, where I told like this image, each pixel, which we call it as a neuron, that acts as an input layer. To pass this image to the neural network as an input layer, before that we have to do some convolution method that is suggested by the convolution neural network, that is called as CNN. Got it? So when we have an image, instead of passing your image directly to the neural network, which acts as an input layer, before that you apply some more steps, which is explained by CNN. So CNN goes with its own concept. You follow that concept, apply some more steps, and then pass that one to the neural network. So your results will be much more better. That is what CNN is going to explain. Clear? So we have to see neural network theory is separate and CNN is separate. So CNN first, our input data is passed to the convolution layers. So there is something called as a convolution. After that, the result of that convolution is passed to the network layer, that is the neural network, which acts as an input layer. Then the hidden layers of the process will start. Now we'll see what is convolution. Clear? So regarding convolution part, there is one more document here, CNN document. This is quite big document. It is having 20 pages. So I'm just going to explain the key points of it. Clear? So here the complete concept of CNN has been explained in a stepwise, right from beginning, from scratch. So you see, I'll just brief it. If you observe here, the same CNN, some images. So this is like how image starts. This image I copied in my slide also for explanation. So like that, it is getting into the means in this document we can find explanation of a CNN right from beginning from the image. So I'll explain some key points over here. So now you can see like animal classification. If you want to classify in the output like bird, then sunset, wait a second, dog, cat, and all. If you want to classify, this is the neural network layer. Before that, you apply some convolution concept for your input image, right? So the convolution concept is applied. So same thing here also, some convolution concepts are applied and it is used. So introduction, some definitions and all we can find about CNN. So I'll get straight away, I'll get it to the main points. So here in this document, basics about image and all has been explained. Images of 3-layer, intensity value, all those things has been told. So what computer do structures? Okay, the first layer. So now we are into the concept of CNN. Okay. So the first layer in a CNN is always called as a convolutional layer. So we'll call it as a convolution layer, the first layer. Okay. So that is now the input. Now the convolution layer is taking the input. So what we are going to do it here. So here we get with some more technical terms that I have listed here. Now with the convolution, we'll see some terms like kernel, stride, padding, pooling, all these things we are going to see it now. Okay. So your input image is there now. That is passed to the CNN. The first layer is called as a convolution layer. Then we can find a word called as a filter or as a kernel. It is called. Don't use the word neuron because that will get confused for us. So filter or a kernel. So first we'll see what it is. So we have to select something a filter as like 5 by 5, 3 by 3, something a filter. We have to select it. So here that filter they are telling like a flashing light, a shining kind of thing they are telling. But basically it is like a key point or a key features or the observations what we do in a first shot, or we can tell as a shape, curve. These all acts as a filters. So I'll just represent it where it is. Just a moment. Okay. Now we'll see what is the meaning of a filter first. Okay. Now, see, if you are seeing this mouse image, our key observation when we see through our eyes, how will observe? Will we observe the pixels which is coming in middle of the ear completely with the white? So these pixels we won't observe, right? We'll observe these things because here some shape and textures are quite different, right? Some edges formations are quite different, so easily we'll observe these areas, right? Then you can observe the tail portion, so like that, because we know these things, right? So when you are finding a bird, how we recognize it's a bird? Based on the mouth, the beak portion, how it is there, based on the what we call the legs, we call palm, right? So that how it looks. So based on that, we can recognize it's a bird right now. So there are always, when you see anything, there are something called as a patterns or the key points, features where our observation goes over there. So that thing we have to extract it, and based on that only the overall recognition is going to happen. Clear? So here also, when we tell about those key points, it can be like some edges, simple colors, or with the curves and all curves, edges, and colors. All these things can be considered as a key points. So combination, a few pixel combinations. So now in this, see, this is one big image, right? So in this big image, this shape, if you consider this curve, if you consider as a key point, so there are some few pixel combination of this key point. This key point, we have to consider it as a filter, okay, filter or as a kernel, and it will be of a smaller size like 5 by 5 or 7 by 7 or 3 by 3, like that. Okay, a small size we have to consider it as a filter. So now that filter we have to apply for the our input image. So when we apply our filter to the input image, that will happen as a first layer of the convolution. So we are applying a first convolution process. See, we can say as the filter. So the filter which we selected like 5 by 5 here. Okay, how the filter is selected? Filter is selected based on the curve, shape, or color, some key points kind of thing. It will be of a smaller size. That filter we have to pass for the complete image. So as the filter is sliding or convoluting, so when you are moving that filter around the input image, so we'll pass throughout that image. Okay, and we'll get when you pass that one, you will come with the next layer, so that you can see it here. The first point what we are trying to understand is the meaning of a filter or a kernel. So how that filter is decided based on the curve, shape, or texture. A small size of filter is detected, and that filter we have to pass for the input image. So now you can see that input image with all the pixels which are called as neurons. The filter is considered as size of 5 by 5. A 5 by 5 filter is passed on the first portion from the top left. It has been taken a 5 by 5. So this 5 by 5 filter, when you apply for the input image of the 5 by 5 from top, it will be converting it into a single pixel. So we got our first pixel now, which is the again a internal hidden layer of the convolution. Clear? I think everyone understanding it. If you are finding any problem, means if you want me to repeat any concept, I can repeat it also. Fine. So I'll, the filter meaning. So filter is a small portion which is selected based on the curve, shape, or color, which is like a key point or a feature, key features kind of thing. So that filter will be applied throughout the image. Now you can see in this example here, the filter of 5 by 5 is applied on the input image from top left. So when you apply that, that is coming up with a result of a single pixel. So then move that filter to one step on your right, then your next pixel is formed. Again move, then the next pixel is formed. So you can see that concept here below. So you can see here. So here the filter is of a 3 by 3 size, that is represented in a color of red, right? So the input image is of a 7 by 7. For that input image, when I am applying a filter of 3 by 3, the first pixel I got it, right? The first neuron or a pixel I got of a 3 by 3 combination. Then I moved my filter. one step to the right, then I got my second one, which is represented here, green color, right? The movement of in a step of one is called as a stride. So if you are moving your filter, when you are applying your filter on the input image, and when you move that filter in a step of one, okay, that is called as a stride. So if you want, you can move that filter in a step of one, or we can increase that stride number to 2 also. If you are moving in a step of 2, that number is called as a stride. So here you can see this image example with the step of 2. My filter is moved in a step of 2. Okay, that 2 is called as a stride. So here, same 3x3 filter, the red color indication. The first I applied it, that pixel is marked here. It is converted into a single pixel. Then move a stride of 2 steps. So we get the next two. It has moved 2 steps here. Then the 3x3 combination is applied. Your same filter is applied for the next set of pixels in the input image. Then you got this pixel. Same way you complete your rows movement. Then when you come down, the next set again move by 2 steps. The stride value is 2 here. Apply. That is converted into blue color. Clear? So here I explained the meaning of a filter and a stride. So if any member is having any doubts regarding that, this you can coordinate. See, today's session I started with neural network. There some 5 to 6 points I covered over there. I tried to explain the meaning of those points. Then I can get into the convolution concept. Now in convolution concept, I explained about filter and a stride. So regarding this, any doubts is there, you can clarify. I'll just wait for some 2 minutes and I'll continue with the next part. Okay, so clear, right? So in the convolution, we understood the meaning of a filter and a stride. So in this image, the same thing, like how the filter is decided and how that is applied with some small calculation, it has been explained. You can observe that this curve is taken as a small filter. Okay, so that filter, when you apply for the input image, say a filter, when you apply it with some simple multiplications and all has been taken. So that filter, when it matches, so it's going to find out as a key point. Like example, now you assume like I have a bird image and a cat and a dog image. So in the bird image, if I take the beak portion as a filter, that filter, I now one input image came. So in that one, I apply that filter. So wherever the beak comes now, so the surrounding pixels and all matching happens, and that converted single pixel will be having some higher weightage. Now when I apply, so that time I'll come to know that since the filter is matched with this input image where that filter matching happens, so I can consider this belongs to the category of bird or something. So now, if you apply that filter for a dog, the big portion pixel values, that exact matching or the number concepts won't match in the dog image, because in that dog image, the beak related constraints are not there, right? So the combination of those pixels won't be correct. So the matching doesn't happen in a right way. So you can tell like it is of another category. So in that way, internally works. Here in this document, the similar example, we can find it. See, there is one filter for this portion. So how it is applying, how that calculation happens and all is explained. The hidden layers, after applying the convolution part, the filtered output, what we get now, that we can't observe it, because if you take a filter of 5 by 5, it is converted into a single. When you apply your filter of 5 by 5 for your input, the 5 by 5 pixels combination is converted into a single pixel, right? So the way, if you start off visualizing it, your filters with those pixels combinations, yeah, we can't see anything physically. It is a where we can't view any right data in that, because it is one of the intermediate layer kind of thing. Fine. So now I completed the explanation of filter and stride. Now we'll get into the next part. Now, okay. So the next one more concept is there after stride, that is called as a padding. Generally, we tell it as a zero padding. So what that is, see, when you apply your filter, right, for your first input layer, see, if you assume the input layer is of 7 by 7, after applying the filter, because here I'm taking a filter of 3 by 3, after applying the 3 by 3 pixel combination is converted to a single pixel, right? So the full input image is reduced now. 7 by 7 input image is reduced to 5 by 5. So similar way you can observe here also, the input image of 128, sorry, the input image here, it is taken by 32 by 32. So 32 by 32 input image, when you apply a filter of 5 by 5 with the stride 1, so it is reduced to 28 by 28. So the input image reduces. Now consider you have an image where, because some pixels are reduced over there, right? So you have an image where on the edges there are some valuable information may be that. We don't know that, okay? So I have an image where on this edges, because see, the first column, if I take, it is used only once, then it is moved, right? The second column is used 2 times, even for the first filter also, second filter also. Third column 3 times, so like that it is, right? So when you consider the first 1 or 2 columns, the usage of that column for the next process is very less. So if you have some right data, important data on the edges of your images, there are chances that we may lose that data. So that's why we have to apply something called as a padding concept. Padding of 2 by 2 means 2 extra rows on top and 2 extra rows on bottom, 2 extra rows, column on left and 2 extra columns on right will be added, so that you increase your image size, so that your edges, the corner data, we may not lose when we apply filtering method. So you can see here, when you have an input image of 32 by 32, you add a padding of 2 cross 2, where 2 rows, top, bottom, left and right, everywhere you apply it, then start applying your filter. So your input image will be having some covering. So any edges informations are there, the chances are that we won't lose it. Okay. So that is called as a padding. So we call it as zero padding here. It is normally 1 by 1 or 2 by 2. Generally 2 cross 2 is used. Okay. So 2 cross 2 padding is the general method where we use when we want to apply any convolution layer. Clear? So now we understood what is the meaning of a padding. Now, next is the whole CNN cycle before passing your result of convolution to the neural network, it is done in some sequence. So we'll see that sequence now. See, when you have one input image, we have to apply the first convolution. So when you are applying the convolution, you have to select the filter. For that filter, what should be the stride and what should be the padding. Then apply the convolution. After applying the convolution, some problems would have been happened, like related to linear activities and all. For that, we have to apply one ReLU method. Then again apply your convolution. This cycle of convolution, ReLU, and if required, one more step is called pooling. Okay. So first apply the convolution, then ReLU, then pooling. This sequence can be repeated 2 times, 3 times, 4 or 5 times, depends on the problem statement what we have. Okay. See, first for your input, apply the convolution. Then there are some reasons where we have to apply ReLU. Then there are some reasons you have to apply some pooling methods. Okay. So it's a sequence of 3, right? Convolution, ReLU, pool. So this sequence, this 3 constraint sequence, you repeat it twice, three times or 5 times based on your project. Then pass that data to the neural network. Okay, where that acts as an input layer for the neural network. Then in neural network, multiple hidden layers, then the output layer. So I hope all of you can assume these things in your mind, how complicated the whole cycle works internally, right? So if it starts, if you really get to know like how it is complicated, you can take a pen and paper, take one image of size of 3 by 3, write some pixel numbers and apply those calculations. 100% we won't get any right result over there. So it is such a complicated process which our computer is going to run internally. So now we'll see what is that ReLU. So it is rectified linear units. One concept is there, non-linear. So whenever we apply convolution to the any layer, so it becomes a little bit called as a non-linear activity. So that's why we have to apply something called as a to get it into some linearities, we have to apply ReLU layer. Okay, that is called a rectified linear units. That is one thing. So then we'll see what is called as a pooling. So now see, after applying your convolution, then some linear units, then pooling. So in pooling, we have 2 types. One is the max pooling and average pooling. So here in this image, you can see the pooling over here. For pooling also, again, a small filter size is decided, like here 2 cross 2, you can assume. So in this 2 cross 2, means 2 cross 2, 4 pixels are there. If you are going with a max pooling, what is the maximum number that is considered? See, out of this color combination also you can observe 6 is the maximum number. So this is called as a max pooling. Average pooling means again it is taken as an average and that will be assigned for the next layer. Clear? So this is the method of max pooling, and one more is a average pooling where it is taken as an average. So you can observe here, this example is for max pooling. So 2, 3, 6, 8. So 8 is the bigger number. The maximum number is considered here 4 and here is the 3. So you'll get the next part of it. So again apply the conversion layer, then again linear filters, after that again pooling method. So whichever the pooling we are opting in our code, that we can apply. Clear? So again these cycles will happen with the multiple back propagation methods also. So with all these things, our convolution layers and neural networks are going to work. So next we'll see with the program example. In the next session, we'll see with the program example. So here in Jupyter folder, I have the code neural network example. All members can open this code and you can just go through with the points once. I'll just open it now. So in tomorrow's session, I'll continue with the explanation part. So to open the Jupyter files, we have to open the Anaconda prompt, right? Anaconda prompt. So now I have to get into the path. In my system, this path is there. As per your computers, you can check it out. So E drive, then CD, PS, like folder name is there, then CD, industry, folder name, CD, 9 underscore, okay. Then Jupyter notebook. So right now I'm opening the code. See what all I explained in this session now with neural network and convolution layer and all. So we'll see in the program now. Oh, this is my Jupyter examples. So here, neural network example. Don't run this code in your system. See right now the code which I passed, it is with the output. Okay. In your systems, the TensorFlow library package is not installed. TensorFlow and Keras. Before installing TensorFlow and Keras, it requires some Visual Basics related softwares. Okay. So and that requires some 6 GB of the memory. In the yesterday's class or day before yesterday, I told that one. So today I'll send the Visual Studio related softwares in the mail. So whoever is interested to install it, who is having in your system around 6 GB of memory and all, you can download these contents and keep it in your system. I'll guide you how to install it. These two files I'll be sending it in the group, and some installation images are there, how we have to follow it. I'll send those things. Any member who is interested to install related to TensorFlow, who is having that space and all, because it's quite complicated. So you can connect with me through any desk and I'll suggest you how to do that process. Clear? So other members, if you are not interested to install and all means, you can just open this code and you can observe the outputs. Okay. Different stage of the output and all. In tomorrow's session, I'll be explaining these things. Okay. See, we spoke about max pooling, right? You can find that word here, space insufficient. So that's why I'm telling, since it requires some good space around 6 GB and all, if you are interested, you can go for the installation process. Otherwise, you can just check with the output here. Okay. The output of this code won't be so much perfect because I had taken only less data for the example. If you take more data, the accuracy and all can be increased. But my intention is to just explain the overall flow, what all theories we saw, that we can relate with the example so that it's easy for us to remember. So you can see the convolution things and all those library packages you can observe here. The code flow I'll explain tomorrow. So if any member is interested, you can just open this and you can observe the code flow. See the kernel size I told, right? So CNN, we need to configure it. We configure the CNN. We used other algorithms, right? We didn't configure anything. Just from the library, we used it. But in CNN, it comes with few steps with the configuration. So you can find the stridal here, pooling size, okay, max pooling and all if you want to apply the size of that. Right. So your activation, what is the activation part, RELU and all you can find. So some steps we can see here, that which we are configuring, right? So these steps I'll explain. Still some concepts I need to explain, like what's the meaning of a pouch, batch size. So you can see here something has been done and all, right? So the members who are interested, you can open this code and observe all these some points which you are able to see. So in tomorrow's session, I'll brief these things. What all theory we saw in this session, those contents in a practical way, we'll see, taking one example of cat and dog images. So those images are there in this folder, pet images. If you go and observe, so you can find the images here. Clear? So regarding today's session, any doubts, anything is there, you can just clarify.
So the question answer session.
Sir,
Yeah, please.
Yes,
how
ma'am.
are we deciding the number of hidden layers, sir? Depends upon the error in the.
Right. One more point I missed to tell. Yeah, just a moment. I'll answer for your question now. Okay, see here in this document it is mentioned, if you can just observe it, how do we know like how many layers to use, how many convolution layers, what should be our filter size, what is the striding size, padding size. See all these things, there is no standard at all. Okay, none of the research people or who are used it, they have not mentioned any standard for this thing. Like for this kind of input, you have to follow. Should be your filter size, how to select your filter. Nothing standard is there. Everything goes with purely on lot of trial and error methods. And exactly based on what data we have, what is the input, and how fast the prediction should happen, what answers we have to get. So it is nothing like any standard. These numbers are not fixed. With individual human experience, working with multiple sample codes or examples, we will come with some decisions. Okay, so that goes with the practice. There is nothing standard for this. Okay. So right now we are just following some 2-layer or 3-layer. Stride and padding is fine. Zero padding, if you consider 2 is fine. But simply giving a number of 2, 3, 5. See, if you give lesser numbers, it takes a lot of time. If you give higher number, it goes with faster times. So the processing, understanding that input image will happen faster. So obviously it's going to miss some of the key factors. So it purely depends on what data you have and how you want to predict it. Like example, if you have a big image, okay, and if you want to detect that it's a cat or a dog, throughout that image, somewhere some key points match, we can tell like it's a cat or a dog. Now assume like you have a medical image, okay, where every point you have to observe it in correctly. So if you miss telling any few points, small pixel combination, if you miss of analyzing it, then you may end up with telling wrong results, right? And that creates a big problem also. So that time your all these layers has to work still in a different format, but there is nothing called standard for this at present. Okay. And a lot of basic convolution, what we are seeing, this is like we are configuring it. Okay. Based on these standards, we get like in TensorFlow, that is with the Google, right? So where we get some ready packages, ready libraries using, they have made with all the analysis, they made a lot of standard packages and they'll release the modules. That module you can download and you can go for the prediction also. Mainly for object detections and all, we get a module to detect it's a mobile or a human. There is one YOLO library is there, YOLO. That also works on convolution layer only. So some people, what they are doing is they are configuring, they are doing all the research and they are giving training with huge data also. Like now I want to work on animals. I'll take some 50, 100 types of all the wild animal, pet animal, every type. I'll take each type of animal with 10,000 images and I'll work multiple times with seeing what is suitable. And the final one model, I'll build it. That model I'll release in the internet and I'll tell like this model is having the data sets of so and so animal classes. You give any animal, it's going to detect. You just use that model in your application, you detect that animal and you go with other process like animal detected. So you count that animal or near a forest, outside the forest boundary, if animal detected, you send an alert to the concerned authority. That is the next level of work. Okay. So like this, the work will be splitted into multiple stages. Right now, I have seen in internet, many companies are coming out with basically with CNN, giving their own name. Like I told, one is YOLO, YOLO. Like that, n number of algorithms are coming in a very fast way. It is coming where they are building those models using all these convolution theories, neural network. They release the model and they tell that this model works with all these kind of data set because they are trained for all the data sets. You just download that model and apply your testing data. So it will come with a result. Okay. Next, any other things are there you can discuss? Any doubts, anything?
Any more doubts?
You can tell, sir.
Any more doubts?
Okay, one more thing which I want to convey is especially on CNN, that means basically on neural networks. See, we understood like a lot of things comes here, you need to configure it and nothing is standard, right? So there is a wide scope in this area to get into the research or a lot of PhD works or anything can be done because we get this data in a raw format, means the working with algorithm in a raw format, where we can build up our own strategies for this, like why I should use straddle as a 1, 2, or 3, or padding or the filter size, why I'm specifically with this, and getting into some specific examples. Like I told with the animals as one example, specific area where you get into a lot of data sets, you create your own data sets, you spend time and money, everything. Means we can build that process. A big research concepts can be worked on these things, and to release your own model, telling that following all these cycles with all the inputs, with these things, I came up with my model. In my model, I have followed these steps. I maintained a convolution of 5 layer. I maintained a hidden of this thing. So many steps can be followed. This can be taken as a small research, also big. So any wider level, it can be developed, because a lot of floating points are there here. Nothing is finalized, nothing is standard. So it gives an open playground for everyone to come up with their own strategies and prove their strategies with the specific application areas. And you can release your own models, kind of. Okay, so any other doubts, any clarifications is there? Can discuss.